Hi everyone. Today we're going to be completing our notes on 7-6 factoring ax squared plus bx plus c. In the previous lesson, we learned how to factor x squared plus bx plus c, or where that leading coefficient is equal to 1. In this section, we're going to see examples of where that leading coefficient is not equal to 1, or where a is not equal to 1. So examples of this would be where we have 6x squared minus 23x plus 20. That would be where that leading coefficient is 6. Okay? So an example, 3x cubed plus 15x squared minus 18x. First thing we check for always is a GCF. So I'm looking for a GCF of 3x cubed and 15x squared and negative 18x. So the way that I can do this is I can find the prime factorization of each of those terms and find the common factors of those prime factorizations. So therefore, these each have common factors of 3 and x. Therefore, the GCF is 3x. What's left inside in that first term, what we didn't factor out was 2x's or an x squared. For the second term, we didn't factor out a positive 5 and an x, so we have 5x. And then in the last one, we did not factor out a negative 3 times 2 or negative 6. Once we factor that remaining trinomial, so x squared plus 5x minus 6, I notice that can be factored further. We're looking for factors of negative 6, c, that add to positive 5b. So those two factors are negative 6 and positive 1. So we have 3x times the quantity, x minus 6, and x plus 1. Okay. All right, let's try some. Here we have example A. First thing we check for is the GCF. So I notice that in 5, negative 35, and 50, the GCF is 5. There is no common variable factor, so we're just left with 5 as the GCF. What's left inside is x squared minus 7x plus 10. We're dividing out 5 from each of those terms. Okay. I notice that the resultant quadratic trinomial can be factored further. Factors of positive 10 that add to negative 7. The answer, negative 5 and negative 2. So our complete factorization is 5 times the quantity, x minus 5 and x minus 2. Letter B. I notice that from negative 6, negative 30, and negative 24, the GCF is negative 6. And from each of those terms as well, there is a common variable factor. We can factor out in total 1x from each of these terms. I notice that that's the most that they each have in common, is just 1x. Therefore, once we factor out the GCF of negative 6x, what's left inside is positive x squared, positive 5x, and positive 4. So factoring out negative 6 from 6, we get 1. Factoring out negative 6 from negative 30, we get positive 5. Factoring out negative 6 from negative 24, we get positive 4. Factoring out x from All right, let's try another. Example B, here we have negative 6x cubed minus 30x squared minus 24x. I notice from the coefficients, we have a greatest common factor of negative 6. Negative 6 divides all three of these coefficients. We also have a common variable factor, so the amount of x's that we can take out from each of these terms, first one has 3, second one has 2, third one has 1. The most we can pull out of all three of them is 1. So our GCF is negative 6x. When we divide out our GCF of negative 6x, well, from the first term, we've divided out negative 6 from negative 6. That's equal to 1. Dividing out an x from x cubed gives us x squared. So we have 1x squared for the first term. The second term, dividing out negative 6 from negative 30, we get positive 5. And dividing out x from x squared, we're just left with 1x. Finally, dividing out negative 6 from negative 24, we get positive 4. And dividing out x from x, we have no x's. And so we just have positive 4 here. This quadratic trinomial can be factored further, x squared plus 5x plus 4. We're looking for factors of 4 that add to positive 5. The answer, positive 4, and positive 1. So the complete factorization is the GCF, negative 6x, times the quantity x plus 4 and x plus 1. Okay, let's try a different kind of example. Example 2 here, 6x squared plus 11x plus 4. So first thing we check for is the GCF. The GCF of 6, 11, and 4 is 1, and there is no common variable factor. So therefore, there is no greater common factor than 1. So we factor a different method. So we find the product of a and c. As a reminder, all of these quadratic trinomials are in the form ax squared plus bx plus c. So that tells me a is equal to 6, that's the leading coefficient, and c is equal to the constant term, 4. So therefore, a times c is 24. Okay? We're looking for, and b is 11. That's that middle term. So we're looking for factors of positive 24 that add to 11. So consider some of those factor pairs of 24. We have 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's it. So of those 4 factor pairs, which 2 add to positive 11? I'll give you a moment to think about it. The answer to that is 8 and 3. So the factor pair 8 times 3, multiply to 24, but also add to 11. So what we're going to do is we're going to write this as 2 binomials. We're going to take that leading term, 6x squared, and I'm going to take the leading coefficient and put it in front of x. So 6x and 6x. Be careful because this is not equal to, if I were to multiply 6x times 6x, that would not be equal to 6x squared. That would be 36x squared. But for the sake of factoring this, we're going to write out 6x and 6x. And then we're going to write that factor pair. We said positive 8 and positive 3. We're then going to divide out the GCF. I'm going to change this to say divide out the GCF of each binomial. So from the first grouping, the GCF of 6x and 8 is 2. From the second grouping, the GCF of 6x and 3 is 3. So after dividing out the GCF of each of the groupings, we get 6x divided by 2 is 3x, 8 divided by 2 is 4, 6x divided by 3 is 2x, and then 3 divided by 3 is 1. So this is the factorization of this trinomial, 6x squared plus 11x plus 4. We can check this by distributing. Using the distributive property, multiplying these two linear binomials, we can find that this is equal to the quadratic trinomial that we started with. So we get 3x times 2x is 6x squared, 3x times 1 is 3x, 4 times 2x is 8x, and then 4 times 1 is 4. When we combine those like terms, we get 6x squared plus 11x plus 4. So that checks out. Okay, let's try a few more. Flip the page. So letter A, we're going to factor completely. First thing we check for is the GCF. The GCF of 10x squared, 17x, and 3 is 1. So we can't factor out a GCF. We're then going to find the product of A and C. So A times C, or 10 times 3. 10 times 3 is equal to 30, so we're looking for factors of 30 that add to 17. So remember those factors of 30. 1 and 30, 2 and 15, 3 and 10. So the factor pair that adds to 17 is 2 and 15. So we have 10x and 15, and we have 10x and 2. Factoring out the GCF, well, the first one, we have a GCF of 5. In the second grouping, we have a GCF of 2. And so what's left over is 10x divided by 5 is 2x. 15 divided by 5 is 3. 10x divided by 2 is 5x. And then 2 divided by 2 is 1. All right. So this is the factorization. I'm going to leave the check up to you. So use the distributive property to check and see if we get back to the original problem. Part B. So first thing, check for GCF. from 2, 1, and negative 21, those coefficients, I notice that the GCF is 1, and there is no common variable factor, so we can't factor out a GCF here. We then take the product of the leading coefficient and the constant term, so 2 times negative 21. Watch those negatives. This is equal to negative 42. So two numbers that multiply to negative 42, but add to 1 here. That coefficient of the linear term is 1. The answer, positive 7 and negative 6. Okay, so I'm going to write this as 2x plus 7 and 2x minus 6. When we divide out the GCF, well, the GCF of the first grouping, is 1, whereas the GCF of the second grouping is 2. So dividing out 2 from the second grouping, we get the first grouping stays the same. GCF was 1, 2x plus 7. And then we have 2x divided by 2 is x. Negative 6 divided by 2 is 3. So we get x minus 3. All right. Again, I'll leave that one for you to check. Letter C. First thing we always check for is the GCF. 21, negative 35, and negative 14 have a GCF of positive 7. So I'm going to factor out positive 7. There is no common variable factor, so what's left inside is after we factor out 7. 21 divided by 7 is 3, and then we have x squared. Negative 35 divided by 7 is negative 5, and then we have x. Negative 14 divided by 7 is negative 2, and there are no x's. We find the product of a and c, so 3 times negative 2 is equal to negative 6. So we're looking for factors of negative 6 that add to negative 5. The answer, negative 6 and positive 1. So when we write this, we have 3x minus 6 and 3x plus 1. Finding the GCF of each of these groupings. In the first grouping, we have a GCF of 3, so we can divide out a 3 from both of those terms. In the second grouping, the GCF is 1, so nothing to divide out there. So we have 7 times the quantity. 3x divided by 3 is just x. Negative 6 divided by 3 is negative 2. And then we bring down our 3x plus 1. One thing to note about this problem, when we factored out that 7 as the GCF, that just gets carried along for the ride. That follows through every single step. All right? Again, I'm going to leave this distributing back to you and see if it gets us back to the original problem. All right, last one for this set is part D. So we have negative 4x squared minus 13x minus 3. I always like to divide out those negatives, so I'm going to go ahead and divide that out. There's no greater common factor than negative 1, so that's just going to be our greatest common factor here. All that's going to do is flip the signs of each of the terms here. So we have a positive 4x squared, a positive 13x, and a positive 3. Now we find the product of a and c, so 4 times 3 is 12. So factors of 12 that add to 13, the answer is positive 12 and positive 1. So what's left over is 4x plus 12 and 4x plus 1. All right. We divide out the GCF of these terms, these groupings. Well, the GCF of the first grouping is 4. GCF of the second grouping is 1. When we divide that out, we're left with, well, 4x divided by 4 is x, and then 12 divided by 4 is 3. And then we bring down our 4x plus 1. All right. All right, example 3. Factor the trinomial to find all possible dimensions of the rectangle. So I see this rectangle here has an area of 5x squared plus 17x plus 6. So it's this quadratic trinomial expression. I also know that area of a rectangle is equal to length times width. So if I were to say that we have this rectangle here, we would find the area by multiplying the length times the width, whatever those quantities are. So if we know that the area is equal to 5x squared plus 17x plus 6, all we have to do is find expressions for L and W and multiply them together, and that's going to give us the area. Or in other words, L and W are factors of the area A. All right, so we're going to factor this trinomial here. So I notice that we have, I'm going to write this as equal to 5x squared plus 17x plus 6. Factors of 5 times 6, so factors of 30, that add to 17. The answer, 15 and 2. So this is equal to, we have 5x plus 15, 5x plus 2, and then we divide out that GCF. So 5x and 15, GCF is 5. 5x and 2, GCF is 1. When we divide out that GCF, we're left with x plus 3 times the quantity 5x plus 2. So expressions for the length and width can be 5x plus 2 and x plus 3 in either order. Okay. Example 4. This is our last one for today. Describe and correct the error the student made when factoring 2x squared plus 15 plus 11x plus 15. Okay. So the student found the product of a and c, 2 times 15, to be 30. We're looking for these factor pairs to add to 11. So the student found each of the factor pairs of 30, 1 and 30, 2 and 15, 3 and 10, 5 and 6. Excellent. Factor pairs that add to 11. Out of these factor pairs, the only one that adds to 11 is 5 and 6. The student correctly identified the factor pair. However, when the student factored this, the student found the factorization to be x plus 5 times x plus 6. If we were to distribute this back into, or multiply these two linear binomials, we would get x squared plus 6x plus 5x plus 30, which gives us x squared plus 11x plus 30. This is not equal to the original quadratic trinomial, 2x squared plus 11x plus 15. So let's try and factor this on our own and see where the student went wrong. So we found, again, that factor pair is 5 and 6. So we have 2x plus 5, 2x plus 6, and then dividing out the GCF from the second grouping, GCF is 2, we get 2x plus 5, and then x plus 3. Okay, so this looks a little bit different than the student's answer. I noticed that those first terms in the factorization are both x, where it should be 2x and x. Likewise, the second terms in these factorizations are 5 and 6, when it should be 5 and 3. So instead of this being a 6 and this being a 1, that factor of 2 goes into this x here, rather than into this constant term here. All right? We're going to get a lot of practice on this in class, so we'll see you tomorrow. Have a great day, everybody. Goodbye.